Hello guys, happy to be here. Amazing event, so many people. It's really cool. Distributed lab rules. So, thank you for introducing me. I am Alexander Ivanov, or Sasha Ivanov, founder of Waves platform. What we are doing, we are trying to create some viable alternative to Ethereum, probably. We are developing an open blockchain platform that can be used by business right here, right now. And important here, open. We want to create an open blockchain platform and usable for business now. So, of course, we face different challenges on this way. All systems like Ethereum and other systems face the same challenges, and I'll try to describe, get a little bit more technical maybe, and try to describe what are the big issues in open blockchain development now. And of course, in 20 minutes talk, it's impossible to cover all the topics, so probably I'll cover only the topic that we are working on at the moment. And of course, what is blockchain now? Yeah, mostly the only production system that uses blockchain technology, open blockchain technology, is Bitcoin. You have to be really clear about it. The only production system in open blockchains is Bitcoin. All the rest is not ready for production. Yeah, maybe someone wouldn't agree with me, but it's sad truth. So, but to really use the potential of blockchains, you need something more than just money transfer, because it's in distant future, it's going to be some kind of distributed database. And it's not about money, it's about decentralization, storing data, and all kinds of transactions, not only money transactions. So we need some kind of blockchain to zero with tokens, smart contracts, and stuff. Ethereum provides a great low-level approach, but it faces really big scalability problems, as probably most people here know. And it can be solved. There is some roadmap for solving them, but there's still a long way to go. So the question is, can we use open blockchains now for real-world business applications? Because there are benefits of doing so, but how can we be sure that they can be used for business? And at the same time, we have closed blockchains, we have banking systems, we have Hyperledger, we have other systems that are actually working. Yeah, they are good, they are safe, more or less. The question is, permissioned blockchains actually are pretty weird systems, because closed ledgers, they don't need blockchains. I have to be clear about it. The only advantage you get through using blockchain in a closed system is it might be some scalability enhancements, but you don't gain anything through using blockchains in a closed system. Yeah, maybe some people wouldn't agree with me, but it's arguable topic, but it's true actually. So we want to use open blockchains because they are cool, no one controls them. So what issues do we have to solve? And of course, scalability is the biggest problem. As you know, blockchain in Bitcoin is bigger than 100 gigabytes right now. You can't store it on your local PC. You have to have a server to store it. You have, in order to mine, you have to have some kind of a factory at the moment. It's not very usable at the moment. And okay, let's forget about the blockchain size, but there is a problem that many people forget. You have to store the state of blockchain system locally. In Bitcoin case, these are all the unspent outputs. You have to store them. In some kind of Ethereum, in a system with balances like Ethereum or NXT or Waves, you have to store balances. And that storage can be bigger than the actual blockchain. People don't realize that you have to store the current state of the ledger, not only the history blockchain, but also the state. And it can be bigger than actually the actual blockchain. In Bitcoin, it's not the case, of course, because Bitcoin has only one token, a native token. But in any case, you can see how the size, how unspent output size grows with time. Currently, it's 2 gigabytes. You have to store 2 gigabytes of data in order to process transactions in Bitcoin. You have to store blockchain, but you have to store also the state. It can be very big. But let's imagine that we have not one token, but like many tokens, like NXT, BitShares, in some way Ethereum. So the state grows exponentially, and the state storage can become even more complicated than storing the history of transactions that is a blockchain. So we propose a way to not store the data that a miner or a user of the system does not need. For example, you want to track only transactions in one token, that you issued, for example. You issued some kind of cool you've done an ICO, you've raised lots of money, and you want to track transactions in just your token, So how can you do that? But you still need to verify transactions in all the other tokens. So as you know, it's some kind of Merkle tree. I think most people here know what Merkle tree is. And this approach is based on so-called authenticated data structures. So how does it work? In order to verify transactions, you have to store only one cryptographic digest. This is the top hash of the Merkle tree. So how Merkle tree is built, you take balances and you associate them with hashes, then you concatenate them, add them up together, and you build the top hash through this. And you store only this hash. This is like normal Merkle tree structure. So in order to verify the transactions in a certain asset, you have to store only the top hash. And when you send a transaction, you have to prove that you are entitled, actually, to send it. So you have to provide the path. So like the path from your balance to the top hash, like this, all the hashes you just provide and put them onto the blockchain. It makes the blockchain bigger, but at the same time, local node user doesn't have to store all the data because it stores just one top hash of this structure. And you just verify, you prove that you are able to send the transactions. It's a very nice approach, actually, that's going to be used extensively in cryptocurrencies. Ethereum has something similar with Merkle trees, but we develop it and we really think that this approach is going to help us scale blockchain storage better, so state storage better, because it's very important. Okay, so we decided how we can help current blockchain systems store less data. So, but on the other hand, there is another scalability issue. You cannot put too many transactions through the network. What is Bitcoin now? You can push like 1 or 2 transactions through Bitcoin system at the moment per second. You can increase it, of course. You can make the block bigger, and you can reduce the time between blocks by an order, like by several times. But you won't get an order of magnitude increase. It's going to be faster, but not substantially. If you reduce the time between blocks, or if you increase the block, you get forks. I hope everybody here knows that. So the problem is why there is like 10-minute time between blocks in Ethereum, in Bitcoin. Because otherwise you have more forks, and Bitcoin is the safest system which you have now. So they don't want to have any forks. So that's why there is 10 minutes. How can you improve this? We implement so-called Bitcoin NG suggestion by Emin Günsurer, actually a great blockchain developer, researcher. So Bitcoin NG was proposed for Bitcoin, but can only be implemented in POS systems, proof-of-stake systems such as Waves. It doesn't matter. It's like blockchain agnostic approach. So we are implementing Bitcoin NG right now. It also can be implemented in Bitcoin. And the cool thing about Bitcoin NG, it requires just a soft fork. So you can also implement it in Bitcoin. Probably it will be implemented sometime. So how does it work in Bitcoin or in general? You let the miners generate so-called key blocks that contain no transactions. And when the miner generates the key block, he or she gets the right to generate all the blocks until the next key block. So he can just accept all the transactions, and he doesn't have to wait for the generation of the next block. He just pushes all the transactions he sees right into the network. So it can be very fast. You don't have to package all the transactions and wait for the next block. You just generated the key block that contains no transactions. And all incoming transactions you can push to the network immediately after you see them. So it's a very nice approach. It uses the network facilities much better than in current setup in Bitcoin or in all actually, in also proof of stake and proof of work systems. So leader election is done through usual mining procedure, and once the leader, the miner, is elected, he can push as many transactions into the network as he or she wants until the next block. It's a great approach, and there are some issues with proof of stake, realization of it, but we are solving them. And in proof of work, it can be actually implemented right now, so probably Bitcoin guys should really implement this because it's cool. And it can actually allow you to send thousands of transactions per second, even in current Bitcoin network. So we have tokens, we can send them efficiently, and what people do now, they do ICO. Everybody and his dog wants to do an ICO. We've done an ICO too, as you probably know. And we are trying to create a system where tokens can be easily issued and can be easily traded. You don't have to issue them, but you have to also enable effective trading of those tokens. So as you know, all exchanges face big problems with hacks now. I don't know a single exchange that hasn't been hacked. If you name me one, I'll be grateful to you because I don't know any. All the big exchanges have been hacked. It's a big problem, and it's like conceptual problem because you deal with decentralized system in a centralized way. So you deal with like decentralized systems, but you just store all those decentralized tokens in one place. So you're asking for trouble, and the trouble just arrives, sooner or later. So but on the other hand, centralized exchanges are cool because people are used to them. You just, you want to have fast trading. You don't want to wait for blockchain confirmations. You want to do high frequency trading, for example. So is there a way to combine them both? Can you combine the speed of centralized exchanges with the security of blockchain? So we are proposing the solution. It's going to be launched. We have it on the back end. It can be tested. Now we are launching the front end. These days, within several days, we'll have it on testnet, and you'll be able to test it. So the solution is like this. You have a centralized matching engine. What is matching? You send orders. For example, you as a trader send an order to buy some token, and the matcher finds the opposite order and just matches them. So we create a system where we have centralized matching and decentralized order settlement. So all orders are matched in a centralized way, in a very fast way, like at Polonix or at any other exchange. But the actual transfer is made on blockchain. So you don't have to trust the node, the matcher, with your money. But at the same time, you can have fast trading. So this system is actually simple conceptually. Yeah? There are some issues to take care of on the level of security, but you will be able to test it within several days on our testnet.
Sasha, just a few minutes.
Yeah, cool.
Thanks.
I'm finishing. Yeah. So, and the last thing I'd like to cover is smart contracts. So, as you know, smart contracts are very cool. People just want to code. Why Ethereum is so successful? Because people can come to Ethereum and start coding. Coders want to code. This is like the most important thing why Ethereum is so attractive. Because you are in this ecosystem and you can see the actual code, the actual frameworks for coding. So smart contracts are big. People don't really realize how to use them to the full capacity yet, but they will be big. I don't have any doubt about this. So, but Ethereum has big problems with scalability. They chose a very basic approach when all the nodes have to execute all the contracts in the network. It's cool, yeah, but you can't scale it. If there's some production level activity, Ethereum just dies. Yeah, it just can't work. So, and the key thing here is it's Turing complete. So it's possible to execute any type of code. What would be if you just limit it to some non-Turing complete, but at the same time usable and sensible language? That's what we are proposing. That's what we are starting to work on. It's a Sigma state protocol. It's a very low-level cryptographic protocol which generalizes the Bitcoin scripting in a way. It's not what Ethereum proposes. It's some kind of authentication language. So in Bitcoin, you have to match a script at a certain output with certain inputs, so the transactions goes through. In Ethereum, it's different. You just sign a transaction that contains the contract, and it has to be executed by all the nodes. We developed some other approach. It's like authentication language, a low-level cryptographic authentication language that generalizes Bitcoin approach. And it allows for like 95% of all the use cases of Ethereum. So you can, for example, do even an ICO here. So for example, you can create a contract that is not Turing complete, that for example, accepts money at a certain address, and if the crowdfunding goal is reached, it sends the money to another address. If it's not reached, it sends the money back. It can be done without any kind of Turing complete languages. You have to realize that. So I'd like to reiterate, you can have like 90% of all use cases in Ethereum with non-Turing complete language. So it doesn't have to be Turing complete. And at the same time, you get multi-signatures through this. You have ring signatures, what Monero has, and very many contracts such as crowdfunding. So I'd like to just summarize a little. So we want to create a system that can be used right here, right now. So the key to success here is scalability and usable smart contracts. So we have a roadmap for all of these things. And I think that we are just at the beginning of the road. After all, blockchain systems have been developing like since 5 years. Yeah, so it's just the beginning of the technology. And you have to realize that all those systems are not so safe yet. Yeah, like Vlad Zamfir recently wrote a great tweet that Ethereum is not safe for development because, and he's one of the leader of Ethereum community. So you have to realize that we are not ready yet to make it like, production ready. Yeah, we have to work on this. But we have this roadmap, and I think we're going to implement it, and within 3, maybe 5 years, we'll have open blockchains that are usable, that are safe, and the future lies in the open blockchains, not in the closed systems. I'm sure about it. Thank you very much.